First, I will talk about, okay, I will start from the beginning just here. Sir, in diamagnetic material, induced magnetic field is opposite to applied. So net magnetic field decreases. So B becomes less than vacuum. That means mu becomes less than mu naught. That means mu R becomes less than 1. Mu R becomes less than 1 means xi becomes less than 0. That means xi is negative, but all negative values are not possible, sir. Minimum value of xi is -1. So from -1 to 0, -1 to 0, and 0 is also not possible. Less than 0 is possible. So this is how we are talking about when we are getting all these things. So I'll say xi becomes exactly -1. We get perfect diamagnetic, but such materials, such materials are superconductors, explained by Meissners. So this is how we have talked about. You write the next type of material. Come on. You write paramagnetic. Paramagnetic. Paramagnetic materials. Oh. Paramagnetic material. Yeah. Sometimes you'll get complex due to my handwriting. I know many people get complex due to, because my handwriting is very nice, na. Yeah. If some person is nice, people start getting complex from them. So I think you get complex. Yeah. Okay. Okay. No problem. Yeah. Okay. 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 Now be focused. Just here. Oh. Yeah. So first thing you tell me you have studied in chemistry also. Oh, yeah. You have studied in chemistry also. You tell me who shows paramagnetic property? Which type of, yeah, unpaired. You write. It is property of. It is property of paired electron. It is property of paired electrons. Sorry. Okay. It is property. I was changing the color, so my mind was deviated. Okay. It is property of unpaired electrons. Unpaired electrons. It is property of unpaired electrons. Second point you write. In these type of materials, induced magnetic field, exactly opposite will happen here. In this type of materials, induced magnetic field is in the same direction, previously opposite, now same. In this type of materials, induced magnetic field is in the same direction of applied. In bracket small, actually induced field is not very large, so small induced field we get. In this type of material, induced magnetic field is in the same direction of applied, in bracket small. Hence, net magnetic field increases. In this type of material, induced magnetic field is in the same direction of applied field. Hence, net magnetic field increases, and they suffer. Come on, tell me, repulsion or attraction? Weak attraction. Strong attraction will come for ferromagnetic, yeah, and hence they suffer weak attraction. And tries to move. Yeah, you can say feebly attracted. Weak word is also used, feebly. 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 And they always tries to move from weak field to a strong field. Obviously they are suffering attraction now, so they will try to come, yeah, and they will move from weak field to strong field. Now I'm giving you time of 10 seconds. See all these things. Come on. First thing, paramagnetism is property of unpaired electron. If your body will have unpaired electron, you will get paramagnetism. Second thing, in paramagnetic material, induced magnetic field is the same direction of applied field, but that induced field will be small. For large value, we have ferromagnetic material. So net magnetic field is more. And since induced magnetic field is the same direction of applied, now they will suffer attraction, weak attraction. Strong attraction will come for ferromagnetic material. They will suffer weak attraction. So they will always try to move towards the stronger magnetic field to get more and more attraction. Everyone understood till now? Chamki baat? Yeah, okay. Now I'm going to do the same thing. I'm going to do the same thing here again in the terms of mu, in the terms of xi. So I think you can do by yourself. First, do by yourself. Come on. Do each and every point. B net greater than B vacuum. That is the first step. That means mu will be greater than mu naught. That means mu r will be greater than 1. That means xi will be greater than 0. Means positive. Means positive. So what do you think? That positive value means 1 lakh, 3,000, 4,000? No, small, because induced field was a small now. So mu is more, but by small amount. Yeah, okay. So this is what happens. Same thing you have done. I think everyone can do. I'll be simply say, sir, induced magnetic field is in the same direction of applied field now, sir. That means net field will be more than vacuum. Okay, no problem. This means mu of paramagnetic material will be greater than mu naught. And I know, sir, mu I can write. Mu will be coming as, sir, mu r into mu naught. So from here mu naught cancel. That means mu r will come greater than 1. That means 1 plus xi. Mu r is also 1 plus xi. 1 plus xi will be greater than 1. Now 1 will get cancelled. So from here you will get xi greater than 0. Greater than 0 means your xi will be positive. Positive xi. But that positive value will be small because induced magnetic field was small. Small means, small positive value means maximum 1.5. They will give you 0.5, xi is 0.5. They will give you xi is 0.25. They will give you xi is 1.2. That is your positive small value. That is xi will be positive. First write this. Yeah, I think everyone has written. No problem. Yeah. Okay. Achha, before moving further, achha, if you observe one thing now, when I talk for diamagnetic also now, I did not put equal to 0. There xi less than 0, diamagnetic xi greater than 0. When xi will be equal to 0? You tell. Nowhere equal was there. Xi here also 0 not included, here also 0 not included. When xi will be 0? No, Baba, for Ferro it's very high value. Hey Bhagwan. Xi 0 means vacuum. Hey Bhagwan. Xi for vacuum. Xi will be 0. You write xi equal to 0 for vacuum. If your xi is 0, that means they're talking about magnetic susceptibility of vacuum is 0. Hey Bhagwan. Because for vacuum, if you do the same thing now, mu of vacuum, yeah, you'll be simply saying, sir, mu will be coming as. For vacuum, if you'll be saying, sir, mu will be equal to mu naught. Mu naught, you know now, mu naught will be coming as mu r into mu of vacuum. If I'm talking about vacuum. So for vacuum, I'm writing mu of vacuum will be equal to mu naught. Mu of vacuum, I can write mu r into mu naught. So from here we'll be getting mu r into mu naught. Mu r I know. Hey Bhagwan, what happened? Mu r into mu naught. Now from here you can say for vacuum mu r will be 1 and mu r you know 1 plus xi, that will be equal to 1. That means xi will be coming 0. Or you can think now what is actually xi? Xi is I by h now. What is actually xi? Xi is I by h. In vacuum is anything is there that you will magnetize? In vacuum, does anything is there that you will magnetize? No. So magnetization of vacuum will be always 0. Vacuum means nothing is there. If something is there, then you will magnetize now. So no magnetization happen for vacuum. So that's why xi for vacuum is 0. You can think like this also. Now understand, I'll be talking about one last situation, one last thing I'll be talking about. Be focused, understand. Acha, you tell me, okay, I will ask you something. We'll talk about ferromagnetism in the next class. In next class, we'll be talking about ferromagnetism. Okay, no problem. But before that, I will talk about one point. You tell me. Acha, what is atomic number of sodium? Just I want to show you something. Oh, sir, 11. Oh, we want this question in NEET exam, sir. Yeah, atomic number of sodium is 11. Okay. Its electronic configuration is 281. Okay, no problem. Which type of material it is? Paramagnetic or diamagnetic? Sir. Sir. Yeah. Why paramagnetic? Why you are saying paramagnetic? Why you are saying paramagnetic? You are saying paramagnetic. Correct. 100%. Why? Why you are observing only unpaired? Here paired are also there, na? Why you are observing that only? Here paired is there, 2 means paired electron. Here also paired electron, na? See this? Why you are observing only paired electron? No, nothing. Outer shell, inner shell, nothing. That has nothing to do with all these things. Always remember, be focused. Understand what I'm trying to tell. We say na body is paramagnetic. Always remember, no, understand. You'll be simply saying, sir, people say like this, unpaired electron, sir. Unpaired electron means paramagnetism. What about this paired electron? Will you not get Yes, you'll get always remember, diamagnetism is a universal property which everybody has. Are paired will be there or paired may not be there. You understand what I'm trying to tell? Always remember, diamagnetism is universal property. Even unpaired the bodies which have unpaired electron, they will also have paired electron. So always remember, diamagnetism will be always there. But in this type of material, what happened? Your diamagnetism is very less in comparison to paramagnetism. That's why we say body is paramagnetic. You write this point. Come on. You write. You write. Diamagnetism is a universal property which is present in every body. Diamagnetism is a universal property which is present in every body. But when unpaired electron comes, diamagnetism becomes less dominant. Diamagnetism becomes less dominant. And body is said to be paramagnetic. Always remember, every body has diamagnetism because paired electron will be always present. If paired electron is always present, means always diamagnetism will be there. But when unpaired comes now, this start dominating. So diamagnetism becomes very less. That's why we ignore diamagnetism. That doesn't mean diamagnetism is not there. Diamagnetism is still there, but diamagnetism is very less in comparison to paramagnetism. That's why we say body to be paramagnetic. Same thing happens if you have ferromagnetic material now. There also diamagnetism is there. Yeah. So if you have ferromagnetic material, then also diamagnetic is there. But again, same thing happen. Ferromagnetism dominates, so it becomes ferromagnetic material. Come on, you write this. About hydrogen, ask from your chemistry, sir. Our basic property of every object is Lenz's law. Even single electron or paired electron doesn't matter. Everywhere diamagnetism is there. Law of nature. Lenz law is one of the law of nature which operates for all electrons. Paired, unpaired doesn't matter. Okay. Okay. Hey Bhagwan. Just see here. Actually, what happens? Let's say, I will give you little more idea. Little chemistry I will tell you. Just see here. Okay. Actually, what happens now? Both are opposite, but not exactly identical. Both are opposite. For example, if this is under the influence of external field, without external field, they are exactly equal. But when you apply external field, if one is, what will happen? Both will slightly vary. Both will slightly vary. One will be coming as, for example, if one has value of 1, other will have value of 0.999999 like this. Variation comes. When you apply external field, both varies slightly. So this difference comes very less now, 0.0000000000000001. But here, if you have one single unpaired, it will completely contribute one now. Even if you have 100, even if you have 100 here, what they will together give you? Even if you have 100 here paired, multiply with 100, almost negligible. Almost negligible. This is completely one. Are you getting the idea? Yeah, that's why this diamagnetism becomes less dominant. If unpaired is not there, if unpaired is not there, who will decide everything? Paired electrons now. If unpaired is not there, only paired electrons there. This will only decide. But when unpaired comes, it start dominating. Are you getting? Paired means subtraction of both of them. Subtraction of both of them will be very less. Unpaired means alone. Unpaired means alone. Are you getting idea? That's why diamagnet, single king, two kings in opposite direction. Two kings in opposite direction. What is the effect? One king wants, two tigers are tied with one string. Two tigers are tied with one string. One is trying to run in east, other is trying to run in west. In which direction system will go? Almost no motion. Almost no motion. But you tell me, if single tiger is there and one string is attached, where he will go? Wherever he wants, sir. Same thing. When unpaired electron come now, they loses their importance. So that's why we say paramagnetic. Yeah. So this is how we can talk about. So this is a slight idea about. So you tell me, come on, which property is universal? Which property is universal? Eating. Human being eat. That property is universal. Eating is universal, sir. Okay. Okay, no problem. So this is how we have talked about. Yeah. This is how we have talked about more situation from here. Yeah. Eat, sleep. These are universal property. Okay. Bye. More situation. Okay. Bye. Bye. STC. Okay. Bye.